So reciprocal, sometimes they call them inverse functions as they go through this one. But basically, here's what we're looking at. Okay, so when we're looking at reciprocal functions, it's f of x equals 1 over x. And again, a lot of times with this one, instead of doing f of x, they may write it as 1 over x. So whether you see f of x or y equals, it's still the same thing, just depending on how you want to look at it. Now, the one big thing on this one is that your x value cannot equal 0. Because if your x value is 0 and you plugged in 1 divided by 0, that if you do 1 divided by 0, you get the nice error message, which means it's not possible. So for these, you cannot plug in 0 to get an answer, which means there's I'd say there's a glitch in the matrix, but at 0, there's a glitch in this graph because there's a number that doesn't exist for this thing. Okay, so we're going to talk about, and I think we kind of briefly mentioned it the other day, but it's called asymptote. So asymptote, this is a line that a graph approaches okay. But never touches. All right. And when you're seeing these on the graphs, we'll show you what these basically they're going to be dashed lines on the graph, and basically it's like cutoff lines. It's almost like you can think about it being like a state line. Like if you're in the state of Alabama, you've got the lines on the maps. Same kind of thing with this one. That's kind of like what asymptotes are. It's like the boundaries. It's saying, all right, for this particular graph, it's going to get close to this part of it, but it's never going to get there. You cannot touch those lines when you get there. Okay, and all these reciprocal functions that we're going to do, they have two different asymptotes. Okay, the first one is going to be a vertical asymptote. And again, math people are great for being kind of lazy, so we kind of do some things short for this one. So instead of writing out vertical asymptote every single time, we're just going to put VA because that's a whole lot shorter than saying vertical asymptote. So it's going to be at x equals 0. Okay, and back up here, forgot to write this down. Okay, so I mentioned it, just forgot to write it. So when you're doing these asymptotes, they're going to show those on the graph with a dashed line. Okay, so we're going to have a dashed line at x equals 0. And again, it's a vertical asymptote, so it's going to be going up and down. The second that we'll have is a horizontal asymptote. Again, for short, we're just going to put HA. At y equals 0. So vertical line going up and down. This one's going to be a horizontal line going side to side. And again, those are basically going to be like boundaries. Those are going to be the edges. You think about it like a fence almost. If you're walking around, you're driving around, whatever you're doing, these are like your fences that, it's the boundaries. This is as far as you can go for this particular place that you're going to. Okay, so what we're going to do, we're going to give you a problem that's basically like this. Now, if the top number is 1, we've got it here. We're going to graph one where the top number is not 1, where it's something a little bit different. And for the most part, all that's going to happen is this top number is going to change. We're doing 1 over x that's here. We're doing 6 over x. It may be 4 over x. It might be negative 2 over x. But basically, we're just going to change the top number. Now, the good thing is the graphs are going to be similar. Just like when we went back and we were doing what we were doing. Oh, the exponential graphs. You don't have to draw this. I'm just trying to give you a thing here. When we were doing exponential graphs, and we had a graph that looked something like this, and this was 2 to the x power, we said, all right, if you graph 3 to the x power, it's basically the same graph, but it's just going to be right beside it. Same thing on these. Whether we do 1 over x or 6 over x or 5 over x or 4 over x, they're all going to be basically the same graph, just off by just a little bit. But again, if we're just graphing one, you're never really going to notice this. Okay, so what we're going to do over here on the side, we're going to make a table of values so we can plug this thing in. All right, again, we're not going to be able to use 0 because if we plug in 0, it's undefined, so it's not going to work. So we're going to pick easy numbers to plug in. We're going to make it be 1. Okay, so what's 6 divided by 1? 6. There we go. So there's our first order pair at 1, 6. If we pick x equals 2, 6 divided by 2 is 3. There we go. If we pick x equals 3, 6 divided by 3 is 2. We're not going to pick 4 because that's 6 divided by 4. That'd be 1.5. I mean, we could do that, but there's not even need of having decimal numbers. We're not going to pick 5 because that's 6 divided by 5. That would be 1.2. So we're just going to pick numbers that are easy. 6 divided by 6 is 1. Okay, so we're going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We'll go negatives here in a minute. 1, 2, 3, 4, 5, 6. Okay, so there's our graph where we're going to go. And we'll graph these points first. So this point is at 1, 6. That puts us up here. Next point is at 2, 3. Next point is at 3, 2. And again, if we had done 4, this would have been 1.5. So if we'd gone to 4, that would have been 1.5. That would put us like here. 5 was 1.2. But we've got 6, 1. So that would put us here. So it's going to look kind of like our exponential graphs. We're just going to curve and do something like this. Okay, so kind of like when we were graphing our exponentials here, this is almost like, instead of an exponential growth, this is like an exponential decay. The difference is we're not crossing any lines on this when we're staying in here. Okay, if we drew the asymptotes, basically we got one going this way. And then we got another one going this way. And those will be kind of hard to see because they're right on top of the x-axis and the y-axis. But basically we got some. And again, these are your boundaries. These are like your fences. So we're going to keep everything in that's in here. All right. All right, everybody go over that part so far? Now, here's where we're going to make the work even easier. We've done x equals 1, 2, 3, 4, 5, 6 over here. You've also got to graph the negative side. But here's the great thing about this one. What happens if you take 6 and divide it by negative 1? Yeah, it's just going to be negative 6, right? So if you take 6 and divide it by negative 2, it's just going to make it negative 3. So if you make the x a negative, it's just going to make the y negative. So it's basically the exact same answers we had, just now they're both negative. So they're either both positive or they're both negative. So now if we go to negative 1, negative 6, that puts us down here. Go to negative 2, negative 3, that would put us here. -3, -2 would put us here. -6, -1 would put us right there. So it's basically the exact same graph, just now it's down here. Okay, so there you go. Now, and again, every graph we're going to do, if this number on top, instead of being 6, if this number on top had been 4 over x, it's still going to look the exact same thing. It's still going to be here. It's still going to be here. If this was 3 over x, it's still here. It's still here. So the only difference is if you graph 6 over x and then we turn right back around and we graph the 4 over x, it might be a little less steep in here or a little more steep, just depending on how we work the numbers, but they're all going to be basically the exact same graph. Doesn't matter whether you put 6 or 7 or 4 or 3 or 2 or 1, they're all going to have this same basic shape in here, so it looks something kind of like that. And same thing down here, same basic shape that's here. All right, now, some of the details they're probably going to ask you on this graph. They're going to ask you for the vertical asymptote. Well, and that's going back up here. We said it's going to be at x equals 0. Horizontal asymptote is going to be at y equals 0. And they are going to ask you for domain and range. Okay. And this one's going to be really pretty easy when it comes off of it. They'll probably show it to you maybe one of two different ways, and we'll show you both ways they might go for this thing. Basically, we've gone from negative infinity to infinity. We've done every single number we can use. The only number we're not going to use is 0. So they may do like negative infinity to infinity and then do a comma and say, all right, but the only thing is we're not going to have x equals 0. Okay. And then the range is exactly the same thing, but the y value is not going to be 0. Okay, and again, all this is the exact same, whether this is 6 over x or 4 over x or 3 over x or 2 over x, all these numbers in here are going to be the exact same answers when it comes off of it. Now, one other option they may let you do for these two, for this one, they may do, and I think we've done this in the past, they may make you go from like negative infinity to 0, and then the u means we're going to skip over the 0, and then we're going to go from 0 to infinity. So they might show that. That's a little bit easier to me than that one, because basically you're just going to tell me what number you're going to skip over. So if you want to use this one, I'm fine with that. I just don't remember in Math Excel which one they use. I have to go back and look and see, and I forgot. I think in Math Excel, they go ahead and give you this, and then over here, you'll just put down the numbers that you're going to skip. So it makes it really easy in Math Excel. I think that's how they do that, but we'll check it here in a minute and see. Yep, that's a U. That's the union. Basically means it's everything up to 0 on this side and everything from 0 out to infinity on that side. Okay, now here's where they make the graph like really easy on these when they go through this parts of it. So as long as the number is positive, like 6 for like this one, the graph will always be here and here. So what they kind of do is they say this, and we'll kind of put this on the next page here. Everybody good there? Everybody ready to move to the next page? Still writing? No, we're good. So we're good? Yep. Yeah, so now I think, and again, here's probably what's going to happen in Math Excel. I think in Math Excel, they're just going to give you this, and this will be here. All you got to do is just fill in these zeros that's over here. I think that's how that goes. Mm-hmm. Yep, that's a U. Yeah. because it's basically it's the union of the everything on the left to the zero and then everything on the right to zero. So yeah, that's a U that's there. That goes back to the interval notation stuff we did kind of early on. We've done interval notation. It's just been a little while, I think, when we're looking at that one. Okay, everybody ready to move on? Good. Okay. Okay, so here's basically what it comes down to. If they give you something like, and again, all the reciprocal functions will look something like this, and basically here's what it comes down to. If that top number, what they're calling k, if that's greater than 0, your graph will always look something like this and something like that. So as long as this top number is positive, the graph will have to look like this. You're saying, what if it's negative? Well, that's the next part of it. If that top number is negative, instead of being in these two corners, it's going to be in the other two corners. It'll be here and here. All right, which means in the homework, this is going to be really, really, really easy because a lot of it's going to be multiple choice on the graphs. Is they're going to give you, I'm going to give you something to work through, and it's basically going to have like 4 options. It's going to have graphs here and here, here and here, 2 here, and then 2 here. And you just got to know that, all right, based on what that number is, if this top number is positive, it has to be here and here. If this top number is negative, it has to be here and here. So that this is an easy multiple choice question just to know if you've got the basics on it of how this thing is going to go. Okay, so again, this was 6 over x, it would look like that. It doesn't matter if this is 6d over x, it's here and here. If it's 16 over x, it's here and here. If it's 26 over x, it's still here and here as you go through this one. So as long as that top number is positive, it will always be there and there. All right, so let me show you like the longest problem like this that you might possibly have, or the toughest, not really long, but all right, so here's a problem that you might have, because some of them they'll give it to you straightforward. This is the only one they'll give to you that won't look exactly like you think it's going to look, but we'll make it look this way just really, really easy for this part. Okay, so you got a graph negative 20 equals xy. And if you notice over here, everything was y equals something over x, and this one doesn't look this way. So for this one, all you have to do for this thing is that we're going to solve for y. Which means to solve for y, that means we're going to divide by x to get the y by itself. Because it's kind of like we were doing yesterday with some of the stuff. It's x times y. So to solve for the x in this case, to solve for the y, we're going to divide by x. And that way this gets knocked out. And now we've got what we were wanting in this case. Now we've got y is going to equal negative 20 over x. Okay, and here's how easy the graph is. And a lot of times people kind of figure out the shortcut on this one. They're like, well, if you got this, if this number is negative, that's just going to be a negative number on top. I'm like, yeah, pretty much. So if you're going to graph this one, again, it's just going to be a quick sketch. This top number is negative, which means, again, if the top number is negative, you're just going to put graphs here and here. So you're just going to draw on a graph here, and you're going to draw on a graph there. And that's all you got to do. There's not really numbers you got to do. You just need to know where this graph has to go. Okay. Again, it doesn't matter if this is -20, -2, -2000. It's always just going to be here and here for these two graphs. Basically, what the number does when you change it here, it kind of changes how far away it is from zero a little bit, but they'll always look just those two things there. Okay, and then last thing we got to look at. Everybody good there before we move on? Hold up. All right, we'll pause. Okay, last thing we have to look at is translations of reciprocal functions. Or to say reciprocal graphs. Okay, so just like when we were doing the log functions, exponential functions, x squared, everything else we've ever done, we wind up having to move it around. And for this one, it's going to be the exact same thing for this part. Now, and I hate that they here's one thing I don't like. Back here, they were using k. When we go to this part, they use a different variable on top. And I wish they would not have done that, but that's just the way they work with it. So it's going to be a over x. So now instead of k over x, they're going to use a over x. And then we're going to have x minus h and then plus k. Okay, these h and k numbers that we've got here, that's going to be the center of the graph. When we were doing this back here, there wasn't any numbers here and here. So the center of the graph was going to basically be at 0 when we were graphing, this thing. So now we're saying, all right, if you start putting some numbers in this fraction and moving it around, basically these two numbers here are going to be where your center of your graph is going to be. Now, and it's still the exact same thing we were doing for the exponentials and the log functions and all the other stuff was with that one. The h value, that's the opposite. Again, h stands for horizontal. That's the opposite horizontal shift or translation. And the k number that's over here, that's your vertical. So basically now because it's a fraction, if the number that's added to x is in the fraction, you're going to go the opposite direction, left and right. If the number is on the outside of the fraction, then we're going up and down. So it's still that same thing. If it was before, it was parentheses or absolute value, square roots. We're doing exponentials, we're doing log. If it's inside or whatever we're doing, it's still opposite direction. If it's on the outside, now it's up and down. Okay. All right, for these, what we're going to do, we're going to graph it. We're going to state the domain and range. State the domain and range. There we go. Okay. And they're also going to make you talk about where the asymptotes are. So we're going to graph it. We're going to state the domain and range. And we're going to do the asymptotes. Now, here's the good thing is, when you talk about the domain and the range, those numbers for your domain and range are also going to be the same numbers you're going to use for your asymptotes. So whenever they ask you for this stuff, it's all the same thing. It's just using the number basically twice when it comes off of it. But the first thing you have to do is figure out, okay, which way are we going to move this thing up, down, left, right? Well, the -3 in the bottom and the +2, that's the numbers that we're going to move this thing left, right, up, down. So this -3 in the bottom means we're going to move it 3 in the opposite direction, not 3 to the left, but 3 to the right. And a 2 on the outside means we're going to go 2 up. Okay, so when you graph this one, instead of being at 0, 0, we're going to go 3 spaces to the right. We're going to go up 2 spaces. And instead of the center being at 0, 0, now the center is going to be up here at 3, 2. Which means all the asymptotes that we were drawing back here in the other graph, they're all going to be basically here. So we're going to draw a vertical line through that point, and we're going to draw a horizontal line through that point. All right, and before we do anything else, is that okay why we're putting that point where we're putting it? Because again, the numbers out beside the X here, those are going to tell us what to do. So the 3 here means we're going 3 spaces to the right. The +2 means we're going 2 up. So instead of drawing the asymptotes at 0, 0, we're going to go over here, up here, and now we're drawing the asymptotes through this thing. All right, now here's where you use your top number to help you know what's going on. The top number is positive, so that means it has to be here. And here. Okay. And if they ask you to graph it, that's all you have to do. That's all I'm asking you to do is just make sure you know to move it up, down, left, right. And again, if this top number is positive, it's here and here. If that had been a -4, then it would have been here and then here. Okay. Everybody okay with that graph? All right, now the asymptotes are really, I mean, this is like the easiest thing in the world, easy on the asymptotes, as long as you know what you're doing. For the vertical asymptotes, that's this number right here. We moved it 3 spaces to the right. That's at x equals 3. So you're just going to put x equals 3. So whatever this number, now you do have to change the sign because again, we're going opposite direction. So this was x minus 3. So when we do the vertical asymptote, it's just x equals 3. The horizontal asymptote is this number that's here. And that's just going to be y equals. And that number, we went the regular direction, so it's going to be y equals 2. Okay. For domain, we're going to go -infinity, and this is the x values. And again, domain is your x values. You're basically going to do this. You're going to go -infinity up to this number. You're going to do the u, put that number again, and then you're going to go to infinity. Because again, we skipped over the 3 because there's an asymptote here. So whatever number you've got in your denominator, that's your vertical asymptote, which is the same number you're going to use in your domain. The 2 you've got here, which was a horizontal asymptote, that's going to be the same number you're going to use in your range. It's going to be -infinity to 2. Jump around that number and then go 2 to infinity. Okay. And it will always work that exact same way when we're doing these functions. So whatever's in the denominator, that's your number that goes with the vertical asymptote. That's the number you're going to use in the domain. The number that's on the outside, that's your horizontal asymptote. That's the number you're going to use in your range. Because again, that's your horizontal, your vertical movement. That's your horizontal movement. So with those two numbers, that's the different things we've got for this thing and how this thing is going to pair up with here. Because again, that's your left-right movement. This is your up-down movement. And because that's left and right, that's on the x-axis. Because that's up and down, that's on your y-axis. Okay, one more example, and then we'll be done. Good, we haven't seen here. Sorry. So let's go negative 2 over x plus 6 minus 7. All right. And again, the very first thing before we do anything at all, we need to know which way we're moving this thing, which way the translation is going to go up, down, left, right. All right. So what's the 6 going to do? Which way are we going with the 6? 6 to the left. There you go. The minus 7 means we're going to go 7 down. So if this is left, right, this is up, down. Again, the big thing to know is down here in the denominator, you're going to go the opposite direction. So plus 6 means you're actually going to go the opposite way. You're going to go 6 left. The minus 7 means we're going to go 7 down. All right, so when we graph this thing, we're going left and down. So you really don't need a whole lot here. Basically, everything needs to be in this lower left-hand corner. So we need to go 6 left. So 1, 2, 3, 4, 5, 6. And down 7. 1, 2, 3, 4, 5, 6, 7. Okay, so 6 left, 7 down would put us right there. Okay, and that's where the asymptotes go. So we're going to have an asymptote going this way, and then we're going to have another one going this way. Okay, and then the other thing you need is, because this top number is negative, that tells us where this thing is going to go. And since the top number is negative, that means we're going here and here. Again, you don't actually have to plot any points. You just need to know where that graph is going to be exactly for that part of it. You're not going to ask for, it's not going to ask you for the x-intercepts or the y-intercepts or anything like that. It's going to be just basically knowing what this thing is going to do and how it's going to go from there. Okay, again, now you are going to ask, should be asked for the vertical asymptotes and the horizontal asymptotes. The vertical asymptote, that's the one that's with the x number. So that's going to be x equals negative 6. Okay. The other number that's out here to the side, that's your horizontal asymptote. That's at y equals negative 7. So the one with the x is your x value for your vertical asymptote. The one that's out here beside it, that's the y value that's going to be the horizontal asymptote. And then again, domain and range are based on those two things. The domain is always the x, so we're going to use this negative 6. Now, if we talk about domain, it's negative infinity to negative 6. We're going to do the u. And we're going to go negative 6 to infinity. And then the range, we'll use the y values because that's what the range is. It's the y values. It's negative infinity to negative 7. And then negative 7 to infinity.